We have here a 100 watt power amplifier module which has problems with self-oscillation. So when we switch it on CW in the 17-meter band and we reduce the power to the min and we start transmitting, in the beginning that is clear, we do not have any signal, and when we start increasing drive to get output power, we recognize immediately that the amplifier has an issue with self-oscillation. So already with only 23 watt output we have the self-oscillation issue, and when we increase power to 46, 47 watt, self-oscillation is going worse. So that is what we don't want to have. On 20 meter we're gonna check the behavior as well, and what we recognize here is so we have the same condition. So drive is closed and it is switched to transmission right now, and well, no output, so that is normal. And now we are increasing drive, and what you see is, so that is a nice sign, and it is 16 watt, and if we going to increase drive more and more, so that is now maximum. Maximum is 85 watt. So what we can say is on the 20 meter band there is no self-oscillation, so that is working as we expected on all the different bands. So that is what we want to have, no self-oscillation. So that is what we are looking for. First thing we want to check before we go ahead for searching for a solution to get the self-oscillation problem under control. We have to check the bias which we need to adjust at the power amplifier. So in the specification we can find that the bias should 200 plus minus 50 milliamps, so that should be bias. And okay, our test leads are already connected right here, and yeah, ampermeter is in place. Our specs manual is telling us we should switch it to a lower sideband, which is already done, and then increase power to the max, which we have done, and without any drive, without NF. So NF is switched off. No NF is injected, and under this condition we should read a bias of about 200 milliamps, and okay, we're gonna switch it to transmit. Now it is to transmit without NF drive injected, and what we can read is a bias of 230 milliamps. 230 milliamps is absolutely in the specs, so we are expecting 200 plus minus 50, and 230 milliamps is fully in the specs, so that is okay, no problem. Maybe we could reduce it a bit. That can't be a fault. So our potty is right here, and now we are going to turn it down a bit to 200. Now we have exactly 200 milliamps, which is what we want to see, right here. So that is okay. But so there was not a misalignment, it was already okay. So that is not the reason for the self-oscillation. So now we need to search for a solution to get self-oscillation under control. So that will be next. Well, this is a wiring diagram of the power amplifier. So this both transistors are the power amplifier, and well, a very well-known fixing possibility is to put a little coil between base of transistor and the lead to collector. If we put a little coil in here, we reducing the feedback, and if we do so, we have a good chance to stop self-oscillation. So what we're going to do is to put a coil in between base and this R17, which is connected via this capacities to the collector, and well, we have it on both sides. We have it here from the base to the collector, so we put a coil in here, and as I already said, in here. So that is next what we're gonna do to stop self-oscillation in the PA. Yeah, therefore we have copper lag wire. So this is wire which is taken to produce coils, and well, so what we are gonna try is to take a resistor. This is 100k resistor, and we are going to wind it around like this. So 1, 2, 3, 4, 5. So that should normally okay. Now we connect it to the resistor leads, and yeah, afterwards we will place it between base and collector on both final stage transistors, and yeah, we hope that we can stop the self oscillation with this little trick. We will see. Okay. So this is the ready coil. We wound it over 100k resistor, and yeah, the inductivity is so that is 40 nanohenry, and that is what we're going to put in between base and connector, and well, the resistor, which we have already seen on the wiring diagram, the R17, this one, and the R18, where is it? R18, this one, are, if we want to find it in here, we can see it here. So that is one of the resistors, and the second one is down here. So that one is the second resistor, and we have to put it in between. So we have to take one side out, the side which is connected to the base, and between base and this resistor we will put our little coil, and then we see whether we can fix the self oscillation issue with it. So screws are out, old screws are out, and power leads are disconnected, corks, connectors are out. So normally I should be able to get the PCB out, and yeah, as you can see, there is still a connector. This is a fan connector. Fan connector needs to get out. Fan connector doesn't want to. So let's check it out here. What's going on? Okay. Yeah, okay. So now it is out. And now we should be able to get the PCB out. Yeah, here we are. So PCB is completely out, and now we have the chance to so now we can put it away, the box, and we can check our resistors, which are here and here, and this side of the resistor, this side is connected to the base of the final transistor, and we gonna take one side out of the PCB right now, and then we put our little coil in between, and then we will see if this can stop the self oscillation or not. So next is now to take these both resistors out, only one side, and put our little self-made coil in between, and then we have to put it back in the cabinet, and we will see if this helps. Our little coils are soldered in, so here is the first one connected to the resistor, as discussed before, and the second one is already in here, so you can see the resistor, and there we have our little coil. Now we can put it back into the cabinet, but first we put some new grease on here, that we have a nice heat flow, which is important for the final resistors, which are getting pretty hot, really getting pretty hot. So that is important to be able to get the heat away from the transistors